Welcome to BrainTalk, a podcast from Project BrainStorm about the bipolar spectrum. Your hosts are Dr. Jim Phelps, a psychiatrist and author of several groundbreaking books about bipolar, and Sara Schley, co-creator of BrainStorm the Film, a documentary inspired by her memoir, BrainStorm, From Broken to Blessed on the Bipolar Spectrum. Each episode of BrainTalk will interview new experts about their research and expertise within bipolar. Let's work together to save lives, end the stigma, and create healing for everyone on the bipolar spectrum and those who love them.
Good morning, Dr. Phelps.
Good morning, Sara Schley.
It's always happy to be a recording day with you because I look forward to it so much. We have a very special guest coming today, and I understand that you're kind of a big fan of Dr. Mary Phillips. So do you want to say a little bit why?
I certainly will. I've been following her work for years. As I've mentioned before, I think she is one of the people in the world who knows maybe the most about bipolar disorders. If you think of bipolar in very broad terms, especially in the realm of what causes bipolar disorder. So I think we're in for a real treat, and it's a privilege today to be able to have Dr. Phillips on with us.
Yeah, with great gratitude, let's welcome Dr. Mary Phillips to Brain Talk.
Hello.
Good morning, Dr. Phillips.
Hi. Thank you, Sarah and Jim, for inviting me here today. Very excited to come and talk to you. Yes, so I'm a Distinguished Professor in Psychiatry in Pittsburgh, and I direct a couple of centres and really focusing on neural mechanisms, so brain problems that are evident in people with a whole range of different mood disorders, but particularly focusing on bipolar disorder, which is, as we all know, so debilitating, covers various different types, and yet very little has been known and very little remains known about what causes it, what are the specific problems in the brain, and how we can try and understand these problems to try to develop new treatments for this disorder that desperately needs new treatment. So that's really what I'm passionate about. And what my lab does is we use different types of brain imaging, neuroimaging, to kind of delve deep into trying to understand what's going wrong in terms of function and structure in the brains of people with the bipolar spectrum disorders. And when we've sort of started to understand a little bit more about what these abnormalities are, that's allowed us to identify what we call brain markers or neural markers. That tells us, well, this is the part of your brain that's not working as well as it should do, or is altered in some way. Sometimes perhaps in a good ways, but sometimes not. And when we understand that, what we can then do is use that to develop new treatments that target, specifically go in to target those changes, those alterations, to try and reverse some of the abnormalities and therefore help people. And we're in sort of early to middle way stages of some of those treatments. And that's what we're really excited about because, before I came to Pittsburgh, it was, I was working in London, which was great. I was doing a lot of brain imaging, but we weren't there yet. We weren't there in terms of understanding what the core abnormalities were in bipolar disorder. And we certainly didn't have the ability to sort of put that into practice in terms of developing new treatments. And that's what I'm so grateful to Pittsburgh for allowing me to do in my lab. So that's what I'm really excited about. And I can say much more about the different types of treatments that we're looking at and developing and how we think that's going to play out in the future.
Well, so Mary, again, privileged to have you here. Thank you so much for coming. And I think maybe a simple question. The question is simple. The answer is not. Your perspective on what do we know now about the causes of bipolar disorder and bipolarity, thinking in those broad terms?
So I can tell you very simply at least to start with, what we think is going wrong in the brain, and what we're discovering is that there are particular circuits in the brain that help us respond to rewards, and these circuits are functionally abnormal, so they don't work well in people with bipolar disorder. They go into overdrive.
Yes.
Sometimes that allows people to be very enthusiastic, very interested in rewards, very interested in going to seek their dreams, to fulfill their dreams, going for their goals. And that's a good thing.
Yes.
But sometimes it goes wrong because people can go do that too much. And they can do that in situations which lands them into problems, taking too many risks.
So you've used the term reward hypersensitivity.
I think that's one way of putting it, yes.
I wonder if I could spring upon you my personal working theory of what causes bipolar disorder,
You go, Jim.
of which that is a part. Kind of 5 different pieces. The first being a genetic propensity to develop differences, brain differences, and then circadian, again, not abnormalities necessarily, but a difference in the way circadian rhythms function in the brain. And then the reward hypersensitivity that you have worked so much on, metabolic differences, differences in mitochondria, differences in the way glucose is managed, particularly in the brain, and then to inflammatory changes, particularly in the gut, changes in the gut microbiome. So we go from genetics to circadian to reward hypersensitivity to metabolic, and finally to inflammatory. Of course, not necessarily in that order, and they all rotate around
Yes.
one another.
Yeah.
Yes, that is the key thing, isn't it?
Yeah,
Because
I like
what
to
is
hear
the order?
that.
The key question for me, well, there are 2 key questions. Because obviously I agree everything Jimmy was saying about, those 5 pillars. I think we can probably add some more as well. But let's start with those 5. The order, what comes first? Is it the genetic? I think that's one key question. What is the order? How do we connect the dots? So that's number 1. The second point, and for me, this is the most fascinating of all, is, as we know, people who suffer from bipolar, who have bipolar spectrum disorders, it's the cycling between different mood states, or sometimes having, depression and mania or hypomania. Sometimes they occur at the same time. Sometimes they're discrete. Bipolar 1 disorder, we tend to think about more as having more discrete episodes of mania, or maybe hypomania sometimes, and then depression, sometimes mixed episode. But what causes the cycling? Why is it that someone with bipolar disorder can suffer so much from having mood that's elevated, hypomania or mania, but also depression, and sometimes at the same time? So what's changed in the brain to allow that to happen?
Yeah, exactly. What single change could cause these differences in these apparently seemingly opposite directions?
Yeah,
exactly, because it's the cycling between the mania, hypomania, and depression which really causes the problems. And I think people with unipolar depression have a terrible time at times, but they have the one pole to deal with, and their journey is to try and stop getting depressed. But people with bipolar disorder spectrums have 2 things to worry about. And particularly when they're trying to treat their depression, the concern is, well, if I treat my depression, that might make me high. And I might not know about it because I'll be so happy not to be depressed. So that's, I think, what makes bipolar disorder a very challenging disorder to study and to try and understand in terms of brain changes. I believe that our work, we're getting close to trying to understand this switch, this cycling, what causes. I'm very excited about what that might mean for developing new treatments.
Can you give us a hint?
Well, I can say it's about the reward hypersensitivity, the reward circuit changes, and how those interact with the neurotransmitters, the brain chemicals that actually allow the neural circuits, the brain circuits to work. And there are key, for those, the key chemicals, the key neurotransmitters, dopamine being one that is very important to drive the reward circuit function. But there's also other systems, other chemical systems in the brain that interact with this core dopamine and reward circuit that kind of modulate this circuit. And I can't say much more, but I think it's the interplay between the dopamine, the other chemicals, and the reward circuit changes.
Stay tuned to this channel next time.
Yeah, I mean, I might be able to say more about that in a couple of years' time if we get the funding to do this next critical stage.
When I spoke to you last, when we had the privilege of coming there to film you for BrainStorm, you had a really good metaphor about the brakes and the accelerator.
So it's like you have I think the problem with the reward hypersensitivity and general problems with the mood regulation is as if you have a lot of gas in your engine with a fantastic car, but you don't have the brake functioning correctly. So it's difficult to have the brake working when it should, and so you're pushing the gas pedal and not able to kind of get the brake working when it should do. Or sometimes it comes in a clunky way, suddenly too quickly, and that is like, suddenly, bang, you go from running around really being really good about yourself and high, and then suddenly, wham, the depression comes in, and that's like someone slammed on the brakes, as opposed to having a brake there all the time in the background that can help modulate so you don't go too high, but you also don't go too low.
Mary, is it too simplistic to say, oh, it's the disappointment that comes from that over expectation, over expectation of reward, and then when it doesn't happen, the disappointment, that's where depression comes from? Too simplistic?
No, actually, there are some models, computer-based models that indicate or suggest that perhaps that is the case for the depression that people suffer from when they have bipolar disorder. I think, the expression would be thwarted dreams or something like that, when you have all these hopes and dreams and then they don't come true, and you're striving for them and they don't come true. But I don't think it's just that, because I think people learn to live with being disappointed. I mean, by the time we get to adulthood, we learn to live with that to some extent. So I think there's something that perhaps a little bit more sensitive than that, that is, has changed in some way. So people with bipolar disorder, are still expecting reward, but at the same time are aware that it might not happen. But at the same time, is still hypersensitive to the potential, that something good might happen.
So then another theory I've heard, which sort of makes intuitive sense to me, thinking about the depression side, which in bipolar depression we know is exquisitely severe, whether it's 1, 2, or anywhere else on the spectrum, debilitating and excruciating, is that it's just kind of like car runs out of gas, like you're out of energy. You've been pushing so hard, maybe not sleeping, maybe another one of your colleagues had talked about the mitochondria not having enough energy, to get stuff done. Does that theory around exhaustion make any sense?
Well, it does. And this is where we're going back to what Jim was saying about the 5 points. If you have this hyperactive reward circuit that makes you hypersensitive to reward, that's fine. It gives you problems, as we've just talked about. But what happens is that eventually you're going to get a kind of burnout, because the dopamine, the chemicals that pushing that reward system into overdrive can't keep up. They just can't keep up. And that, it's a two-way process. It could be that the mitochondria, the powerhouses in the cell, are just not working properly, so they can't give you the energy you need, and then everything shuts down. But it could be that because you have the hypersensitive overdrive reward circuit in the first place, that eventually will burn itself out and will damage those mitochondria, which are doing their best to keep up. But eventually, having too much of these chemicals can be bad for the cells. We call it neurotoxicity, which is when, say too much dopamine, too much chemicals can actually backfire and can cause, there are many words for it, but essentially damaging the cells and making the mitochondria not work as well as they could do. Is it that the lack of energy, mitochondrial cell problems come first, which then affect the dopamine, the reward circuits? Or is it that the overdrive in the reward circuit backfires? It's like a car having too much gas, and eventually it spills and you can get a fire in your engine. And that can backtrack into your cells and actually make them, no longer work as well. And then it's going to take them a long, long time to catch up. And that's that kind of overdrive suddenly backfiring. That's when things stop working, and that's when you get that complete lack of energy, exhaustion. I think even people without bipolar disorder kind of understand that, can feel it, because we've all been there. You've had a baby, or you've been working really hard, you've done all nights, you haven't slept, you become exhausted. What's driven you there is, I've got to meet my deadline, I've got to meet my goal. But eventually your brain gets worn out. So imagining that happening on a more regular basis. And that's what it's like, isn't it, for people with bipolar disorder?
What you just said makes a lot of intuitive sense to me in terms of my own personal experience. And you can't control it, but you can do preventive stuff.
Yes.
So that you don't let yourself stay up 20 hours a time. You don't let yourself, like I just remember I used to go, don't eat, and then crash. Now I know I can't do that.
Well, and Dr. Phillips has also done work on circadian rhythms. And in fact, the interplay between the circadian rhythm system and the reward system is one of the most spectacular parts of what you've been doing, I think. So Could you say just a little bit about how the circadian system ties into the reward system?
Well, yes, my colleague, actually, Dr. Colleen McClung here in Pittsburgh, has done a lot of excellent work on circadian systems using other models, not looking at brain imaging in humans, but looking at how mice behave when they have circadian problems. And so I think we've learned a lot from her work, and she and I have been working together. In fact, we're working together on a big center, a collection of projects right now, focusing on this very question, Jim. So basically, the theory goes something like this. The circadian problems may arise from genetic changes, but those genetic changes also impact the way, as well as doing the circadian changes, so the way you sleep, the way you get up, your timing, those also impact the way dopamine works in the brain. And dopamine, this key chemical, the key neurotransmitter driver of the reward system, the reward circuit. So you can see there's another link there. The same kind of circadian patterns that you see in behavior are also shown in the way dopamine works in the brain. So you can see that if someone's a very nighttime person, it could be that their reward system, their brain system, is going in overdrive at nighttime, as opposed to when it's meant to be, like what's supposedly meant to be during the day. That's arguable about what's good and what's bad, but that's how they're linked. And there are other ways in which they're linked, obviously, but that's a key thing. And of course, then that links the circadian with the reward circuits with the energy problem that Sarah was asking about, in the ways that we talked about just now. So getting back to that question about how these dots are linked.
Yes, wonderful.
I'm trying to draw a systems map here, if you could see all the squiggles here on my pad.
Yeah, I can show you some of mine as well.
My career has been in systems thinking and drawing those maps. And, we talked about, you could think about them as negative feedback loops or positive feedback loops and how it all connects. Very fascinating.
Sarah, just draw a circle around and around and around and around. Just keep going around.
Yeah. Which comes first, right, is always the question.
What comes first?
Yeah. And then, so that would even lead me to Colleen has taught us about the master clock in the brain, right? So you talk about circuitry, but then, which I think of as connections, right? But isn't the master clock actually like a physical, what would you call it, location in the brain?
Well, it is, yes. And Colleen can say a lot more about that. I'm not going to steal her thought. But the key thing is that, what drives circadian rhythms is obviously important for the whole of the body, but it affects the very circuits that I'm interested in, and it's particularly the reward circuits. So all these parts of the brain talk to each other. So the circadian clock, which is in, hypothalamus, I won't go into technical terminology too much, but that part of the brain directly talks to the reward circuitry, and the genetic basis of the circadian activity then gets translated into how the dopamine in the reward circuitry works, and amongst other things, and so that is really, I think, a key point, a key link amongst all these different 5 pillars, or 6.
My map is getting better. Really exciting.
I've always imagined, Sarah, some Cro-Magnon, a really ancient person, lying in his cave at night in the winter when it's dark and cold outside, and they happen to be the one in the band whose circadian system is not turning off at night, and it's driving their reward-based thinking. And they're thinking, oh, if we were to just do this differently next spring, and then they just keep going. So by the time spring rolls around, they are leading the band and having more offspring, and their genetic propensity behavior is getting extended.
Well, there you have it.
Getting the hunt.
Yes, they become leader. However, they could also become exhausted because they're not sleeping when everybody else is. And so during the daytime, when everybody else is out and about, they're now very tired, and they're not going to be able to keep up with the pack. So it could go both ways. Yeah. And I think that's the key. That's the dilemma, isn't it? As we know about bipolar disorder.
Mary, I wonder if you could comment on a case, if you will. A good friend of ours, Major General Greg Martin, who's been on the
Oh,
show,
yes.
and he's very out with the story. So I'm sure he would be fine with us talking with you about it, because he's also, again, been on the show and in the film, et cetera, and books and talks. So from the standpoint of your research and what he shares is like, he was like all over the battlefield, complete full-blown mania, right? And all the stresses of Iraq and commanding 10,000 troops and everything that happened there, and watching, horrible things happen to his troops, and then goes into a 2-year can't get off the couch depression, with no desire to live. So from like the standpoint of your theories and what you've been teaching us, how would you describe what might be happening, what might have happened in his brain?
What might have happened is what we've been talking about. So he's obviously in an incredibly stressful situation. And we know that dopamine, this chemical, helps us with reward, gets the reward circuit working, but it also motivates us. It's a drive chemical as well. First of all, he probably had a super great, ability to bring on dopamine, to bring on this drive. So he was getting out, doing all of these things that most of us wouldn't even dream of doing, wouldn't even be able to do. But he was able to do that from his experience and his ability because of this highly functioning drive reward system. So that's fine. And in the acute, in the situation, you've got the battle, you've got your adrenaline, norepinephrine going on, everything's working, got to get the goal. As soon as that's taken away, and and after a period of time, when the circuits got exhausted, because you can't keep on going like that forever, we get into the situation of the no energy. It's gone. The system's been almost gone into overdrive, and it's almost sort of not destroyed itself, but it's damaged itself. And the ability to get that energy back from the cells, from the mitochondria, the powerhouses in the cells, has been impaired. So, he's a great example. I mean, I'm so sorry that he had to experience all this, but he is a great example of what can happen if this system goes unchecked. Unfortunately, it took its toll on him. Yes. And now, had he been having treatment of whatever form that helped control that reward system a little bit more, who knows what might have happened? Would he have been able to do as well in the battle situation? That's the question, isn't it? Maybe he would have done, but he would have known when to stop a little bit more and take, power breaks. But, there are many ways of dealing with this without having to impair your performance. Because I think that's what everybody's worried about. I want to be like him. I want to be able to do the drive, but I don't want to get to be depressed for 2 years afterwards. So, that's what we're trying to sort out. But yeah, he's very brave and very courageous in also many different ways. I had the pleasure of meeting him briefly at the International Society of Bipolar Disorder meeting in Iceland just a couple of months ago. And yes, he has an incredibly rich story to tell.
Jim, we have a caller on the line. Are we ready to invite our caller?
Well, I have many questions, but I will try to share the floor.
Mary, we have someone calling into the show, and Jenna has a question specifically for you. She's excited to ask and has come on BrainTalk for that purpose. So, Jenna, welcome to the show. Go ahead and ask your question.
Hi, Jenna.
Hi, Dr. Phillips. This is Jenna. I do have a question on cognitive function specifically.
Yes.
And more so about its relation to bipolar disorder, specifically memory, attention, emotional processing, word finding. I'm very newly diagnosed, about 7 months, so I'm still learning a lot. And my question is, why does this decline happen in cognitive function? And is there anything I or we can do to slow it down or stop it?
Well, Jenna, thank you very much for that question. And again, very courageous of you to share some of your story with us. And I wish you the best, with your next steps in your journey. Yes, it's a very important question, this cognitive problems or changes that people have. One of the changes is in attention. So people with bipolar disorder who have not been treated don't have the right treatments, have to wait a long time to get the diagnosis, their attention is a problem. So the ability to concentrate for long periods of time, it goes. Another problem is absolutely what we call executive function, which is the ability to plan, to organize, to think ahead. that's also something that's very, very vulnerable and changes and becomes, doesn't work well after time with people with bipolar disorder. But the good news is that these can change they can get better with treatments. And I can say a little bit more about that in a moment. Obviously, if there's a problem in one brain circuit, it's likely going to spread to the other circuits. And this dopamine chemical that I was talking about in the reward circuit is also very important for the brain circuits that help us concentrate, that help us attend, that help us with memory and all this kind of stuff. So that's how they're linked. So, but don't get too worried because you've been newly diagnosed. But the good news is that a lot of the treatments we have, but certainly some of the newer ones, can help with the cognitive problems. Things like diet treatments, like the ketogenic diet. And there are other new treatments that can actually are being shown to really improve cognitive function in people with bipolar disorder if you're able to go on the diet. So that's one thing to say. So I suppose the bad news is, as you already know, that there are cognitive changes that can occur, but the good news is that these can be helped.
Jenna, I can say that for me, I have had severe cognitive dysfunction when I'm in a bipolar depressive episode, like completely the brain is gone.
Yeah.
And I can happily say that it's back. When I'm well, it's really back. It doesn't go away. But I just want to offer hope that with treatments, with practice, with preventative stuff, you can really have your brain fully back and maybe even better than before.
Right. Yeah.
And Dr. Phillips, you're co-author on a recent paper on lithium, finding that those who were on lithium had a preservation of neural function that others who were not taking it did not. Could you just say a little bit about lithium and its impact on the system as a whole and on risk of changes?
Yes, well, for people that are able to take lithium, and let's be clear, not everybody can take lithium, but for those people who can, it works well. And the reason it does work is not entirely known. We know a lot more about it than we used to, but it is known that lithium impacts the brain by causing bits of the brain that were not working properly to grow back. So I talked earlier about cell damage, if the systems go into overdrive, and that can backfire, like the engine backfiring and causing some damage to the cells. What lithium does is kind of stop that and helps the cells regrow. To put a long story very short. So it's good. It's very good if people can take it. Not everyone can tolerate lithium, of course. But yeah, so lithium is a very old treatment for bipolar disorder, particularly helpful for mania, of course. But it's a very old treatment, and it works very well in a fraction of people. But there are other treatments as well, obviously, that we now are looking at that may be available to a larger number of people with bipolar disorder. Dietary treatments, but also there are other brain stimulation treatments as well that are starting to be looked at. And I'm very interested in that area as well. Yeah. So back to Jenna, I think, Jenna, don't worry. There's, as Sarah said, and as I was saying, there are, and as Jim was saying, treatments can really help with these. You've just got to find a treatment that works for you.
Jenna, thank you so much for joining us. And we wish you the best. Is there anything else you want to share?
No, I just really appreciate you answering my question. Thank you so much.
Thank you.
Okay. Take care. Well, Mary, we could go on and on with you, and we will have to have you back on the show in a couple months or whenever these. It's like a mystery novel. Stay tuned to find out more about what's happening in the circuitry.
It is. One of the talks I gave, Sarah, in bipolar disorder a few years ago, I did compare my journey with mystery novels. I love mystery novels, and I think it's a very apt analogy.
So we do, unfortunately, we'll need to say goodbye for today, and we'll see you another time soon, we hope. Jim, what's your final commentary?
I'm thinking of Dr. Phillips as our chief detective in the mystery story.
Chief Detective Officer. That's a new title for you. Along with
I would love that. Thank you. I'll put that on my door.
It's so great. All right. Well, thank you so much for joining us, Dr. Phillips, and we look forward to seeing you again soon.
Thank you very much.
So, wow, Jim, that was your hero, Dr. Mary Phillips. I can see why. What did you learn that was new today?
Mostly it's wonderful to have an opportunity to just listen to her at length. We just get little pieces sometimes in short conversations and reading papers. And so, yeah, what a thrill reading her work for all these years to have a chance to talk with her like that.
That's super cool. I like this Holy Grail thing, like the mystery novel. Which is it? Circadian rhythms, we've talked about the 24-hour cycle. How does genetics play? What about mitochondria? What about brain circuitry? There's a lot. And my mind is one that wants to fit it all together in a neat puzzle, but it's probably not so neat.
Yeah.
I have a phrase in the book that my kids say, "You wrote that, Mom?" Which is the brain is as vast as the universe and equally uncharted. And I really do like that line. And maybe we'll start charting it now with people like astronauts like Mary Phillips.
Yes, indeed. That's a good way to think of it.
All right. Well, great. Good to see you again. And I look forward to our next time.
Okay, great. Thank you, Sara.
Thank you for joining us on BrainTalk, your bipolar spectrum podcast. BrainTalk is a program of BrainStorm, a multi-platform project about the bipolar spectrum, which also includes Sara Schley's memoir and a full-length documentary. We aim to save lives, crush stigma, and maximize healing for all people living with bipolar and those who love them. For more information, bipolar resources, and podcast episodes, head to brainstormthefilm.com.